answer for number 1 is false. Let me talk about the misconception. Remember, a lot of students are trying to do this. They try to take the exponent and they try to distribute this. And they get an answer of 125 x cubed minus 27. That is wrong. They are not equal. The reason why they're not equal is you can only do this exponent or power rule with exponents, which means that they're all multiplication. Notice that this one has addition and subtraction. So the right application of distributing here has all multiplication there, and you're distributing that 3 to every exponent. In this problem, there's 2 ways of doing the problem. You can write it out 3 times. 1, 2, 3. And then you can multiply these 2 using FOIL or the box. And then whatever answer you get, you can multiply it again, and you'll get a rectangle. Or you can use your formula sheet and recognize that this is your Pascal's triangle. The power of 3 here tells you which row to go in. And then I need my coefficients, 1, 3, 3, 1. 1, 3, 3, 1. And then I start with the a to the 3rd power, and I count down. A2, A1, A0. And then I start with the b's, b to the 3rd power on the right side, and I count down. B 3rd, b squared, b 1st, b to the 0 power. I crossed off in red here all of those that are not important. B to the 0 power is equal to 1. So I don't need to write a 1 here or here. This first power is not important either, and this one and this one are not important as well. So I'll get a to the 3rd, 3a squared b, 3ab squared, and b cubed. Now my a value is 5x, and I'll put that in for every a value with parentheses. And then b value, though, is negative 3. Substitutions in parentheses. 5x cubed, 5 to the 3rd power is 125. X cubed is x cubed. Here I'm going to use PEMDAS, so I'm going to use exponents first in the parentheses. That becomes 25, and this becomes x squared. 25 times 3 is 75. 75 times negative 3 is negative 225. That's why I have subtraction here, not plus. Come over here. I have negative 3 squared. That's 9. 9 times 5 times 3 gives me 135. So this is 135x. And this becomes negative 127. My answer is this polynomial in blue. Raise your hand if you got that. Good. Question number 2. We've been learning about rational functions for the past couple of days. I asked you what the vertical asymptote. You put a line that's vertical. There it is in pink. From the graph that you guys were given. And then how do I get x equals 3? We've been learning about just picking 3 order pairs on the vertical asymptote. So for example, 3, 0. Write 3 up 1. 3 on the x-axis, 2 on the y-axis. And you'll recognize that all of your x values are 3. That's my equation for the vertical asymptote. With the vertical asymptote, this can help us find the domain. Domain goes from left to right, and we're working with the x values. As I go from the left to the right, you can also label your axes with the positive and negative infinities. Over here, the question is, do I have a graph? The answer is yes. It's from negative numbers. And I cannot continuously go through the whole way. There's a break right there. This break in this pink line is at 3. So negative infinity to 3, and then 3 to positive infinity. Notice there's a break here, so there's 2 graphs. 1, 2. That's why there's 2 intervals. 1, 2. They're connected by U, which means union or connection. Connecting these 2 answers. The horizontal asymptote here, do the same thing. Find 3 order pairs. 0, 1. Right 1, up 1. And then right 2 on the x and up 1 on the y. So I have all my y values are going to be 1. And then the range goes from bottom to top. Put your pen there. Do I have a graph down here? The answer is yes. you have the arrow that tells you to go towards negative numbers, so negative infinity to 1, and then 1 to positive infinity. So that's my range. Again, two intervals because there's two graphs. One below the purple and one above the purple. And then the last one is the end behavior. As x approaches positive infinity, remember we talked about this box is always the same. One positive, one negative. So as x goes towards the positive infinity, you look at the end, which is the arrow. That's why they call it end behavior. This number is not going up. It's not going down. It's like a plane or a roller coaster landing on this purple line. This purple line on the y-axis, f of x, the y's, is a 1. And as you go from right to left, going towards x approaches negative infinity, the last thing you have is an arrow. The arrow is not going up, so it's not positive infinity. It's not going down, so it's not negative infinity. It's approaching this purple line, and it's approaching the y values at 1. So our answer is 1. Recognize the colors I try to use there, purple. So your horizontal asymptote can help you with your end behavior.